So I want to know, what is the formula?
What?
She's gonna say they get it.
So using the same method that we went over yesterday, okay? Formula for
Krabby Patty.
Don't like snitches here.
barium
Just don't even guess.
phosphide. That one's a tough one. Good luck. And then
Unbearable.
and then
Bear.
Language. What is wrong with this? Language.
and strontium
You don't get any more.
fluoride. Okay, that's your warm up.
These are fun words.
All right. So go ahead and do that, and then we'll go over the answers. All right. So for the warm up, you needed to write the formulas, and what we were going over yesterday. So especially if you were absent yesterday, make sure you're kind of watching the little process, unless somebody explained it to you. But what we did was we kind of started with Lewis dot structures, meaning we wrote out, like for the first one, we had Ba, okay, for barium. We look at our periodic table and we figure out it's in group 2. So how many valence electrons does barium get? 2. So you should have had 2 dots on it. My bad. And then we had phosphorus right next to it. Phosphorus is in group 15. So 5 valence electrons. So 1, 2, 3, 4, 5. And then we had to figure out how this is going to work, right? So starting with that, you have barium. He's able to give away both of his valence electrons, so he's good. However, phosphorus still needs something, right? So we're going to add another barium into our picture to supply that other one. So what we see is that this one can go right there. Sorry. All right. And then now we have the problem that barium needs to get rid of an extra one. So we're going to draw ourselves one more phosphorus. He's able to give that one away. Ah, darn it. Phosphorus needs 2 more. So we're going to draw one last barium to supply those last 2. And then that should be it. So once you had figured this out, you ended with, so your after picture needed to be BA, BA, BA. Yep. +2.
Wait, we need an after picture.
You should still be practicing it because you will have to do this. So, yes. And then your phosphorus should have had 1, 2, 3, 4, 5, 6, 7, 8. Don't know where that is. Sorry, my bad. And he has a -3. And this phosphorus, it's a -3 with 8 dots. Okay? So once we have that, now we can actually get our final formula, and that final formula we get from counting up. So how many bariums did I have?
3.
3. So I had Ba3. How many phosphorus did I have? 2. And that is the chemical formula for barium phosphide. Okay? So if you kind of remember, I told you that this drawing part gets annoying. I am perfectly aware of that, okay? But you are going to be asked to draw it, and this is how you would have approached this one, okay? So make sure you're still practicing those whenever we have those in warm-ups and stuff. All right, let's look at the other one. We had strontium fluoride. So strontium fluoride, we have SR. He is also in group 2, so we're going to give it 2 dots. Fluoride is in group 17, so he gets 7. Okay, and then we're going to show that electron transfer. So he's able to give 1 away, and then strontium needs an extra fluorine added into the picture. In order to give its other valence electron away, and now everything is good. So we have strontium with nothing around it and a +2 charge. You had fluorine with 8 dots. in brackets with a -1, and the other fluorine with a -1. And now you can get your chemical formula from that, which would be 1 strontium and 2 fluorines, which was your final answer. Okay? Today I do plan on showing you the shortcut, which is a quicker way to do it without the drawings. However, you are not allowed to forget the drawings because you are still going to be asked to draw me an ionic compound and show the electron transfer. So don't forget how to draw them. And some of you guys may prefer to still use that way. Okay, and the shortcut you'll just use for transition and polyatomics. Okay? Are there any questions on this? Okay, cool. So, all right, so with the shortcuts, let's just use the one that we're looking at right now, which is the strontium fluoride, okay? And so basically with the shortcut, we're going to be looking at charges. Now, do we have this information to begin with?
No.
Not really, right? You have to be able to look at your periodic table and know what the charges are for at least all your main group elements, okay? And then when we get Roman numerals, I'll show you guys how to do that, okay? So just remember, on your periodic table, group 1 and 2, it's +1. Whoa. Okay, it's +1, +2, and then you kind of jump across and you get +3. We don't worry about the carbon family. And when it goes -3, -2, -1 on your periodic table, that's what you should be thinking. Okay, yes? All good? Okay, so knowing that, looking back at strontium, at strontium fluoride, okay, strontium is in what group again? According to your periodic table? 2. So what charge does it have? We're not asking valence electrons now. 2. So we have a +2. So we would write strontium with a +2 in the top right corner. So it's kind of like what we end up putting on the brackets, and you'll see that connection here. Okay? And then we're just going to write fluorine. Fluorine is in group 17, so what's its charge?
-1.
A -1. So we're going to put a -1 up here. Okay, so this is what the shortcut is. You take those charges and you crisscross them. So what you're going to end up with now is you're going to have SR. I'm going to put the 1 there, but typically we don't write 1s. F2. Is that the answer we got when we drew it out? SRF2? Yeah. Okay. And so that's where it's coming from. So for strontium fluoride, that one was kind of easier to draw. But if we had something like the barium phosphide that you guys had to draw out a lot, okay, we would look where barium is located. It's in group 2, so what's the charge on barium? +2. Okay, phosphorus is in group 15. Be careful with this one. It's -3, right? This is group 17, this is group 16, this is group 15 right here. So it's a -3 charge. Okay? And now, just like we did in the last example, we're going to take those 2 charges, we're going to crisscross them. Or cross and drop. Okay? So we get Ba3P2. And you can actually rely on that for everything. You can rely on it for your polyatomics. You can rely on it for your transition metals. This is the shortcut. This is the nice way. Does that mean you get to forget how to draw it? No. No, you cannot. Okay, I will be asking you to draw them and show me the electron transfer, so you still need to do it. So make sure on the ones that I'm telling you to practice that on, make sure you're practicing that still on, okay? But now you guys know the shortcut. We will do a transition metal one next. So go ahead and look at your packet. And if you choose to write this in your journal, that's fine. But have your packet at least open to the same page with me so that you know what we're looking at, okay? All right, so a quick example for a polyatomic one. We're just going to take, let's do magnesium. Sorry, I shouldn't have put Mg. Magnesium phosphate. That's going to be the example, okay? All right, so what you're going to see here is why I want you guys to put parentheses around them, okay? So I want you guys to put parentheses so that you know to bring numbers to the outside of them. So when you go to approach this using your crisscross method, so what we just did, the quicker way, we're going to start with magnesium. So where is magnesium located?
In the first row.
Second. So it has a what charge? A +2. Okay, phosphate. That is not phosphide. So what that tells you is you should look at your what? Polyatomic list. Polyatomics. Open it up, look in the middle, tell me the formula. Just get it written.
-3 charge.
But what is the formula? PO4.
1 potassium, 4 oxygen.
And there's a -3 charge at the top. So notice how I wrote that. I recommend you writing it that way. Keep things on the outside because you are not allowed to touch anything inside those parentheses. If you do, you just ruined it. Okay? Do not touch anything inside the parentheses. Leave it as it is. It is phosphate. That is what it is. You cannot change it. Okay? All right. So what we're going to do to get that formula is we're going to crisscross those charges like so, just like we did before. So we're going to end up with Mg3 PO4 inside parentheses and a 2 on the outside. And that's it. You're done. Okay?
So the negative doesn't transfer?
So you do not bring the charge part. So the positive and the negative part, you leave those out. What this just did for you is it did that whole drawing thing by showing the ratio between the oxidation numbers. So if you think about it, the drawing thing, you always ended up with those oxidation numbers, and that's actually what gave you the number that you had. Okay, so it comes from the process that you guys did. It just does it for you by looking at those oxidation numbers. Okay, that is the only way magnesium can fit with phosphate. If there are 3 of the magnesiums and 2 phosphates, that's it. So ionic are very specific to that. They have specific ratios. Yes?
What if there's more than one weight?
No. Okay, now, for example, though, I want to show you one other one with magnesium. What if we had Mg mixed with sulfate instead? Okay. The charge on magnesium is a +2. What's the charge on sulfate? Look it up. Look it up. Hurry up.
-2.
A -2. All right. So crisscross them. We end up with, let me shift this over just a little bit. We end up with Mg2SO4 with a 2. But ionic compounds, and I will reiterate this tomorrow, so if this goes over your head and you're like, what? Ionic compounds are showing ratios. In math class, if you had a ratio that looked like this, would your teacher let you leave it that way? No, they would tell you to simplify it, right, to a 1-to-1 ratio. It's exactly what you do with ionic things. They will simplify to their simplest form, meaning if you can reduce it, reduce it. So if you have a 2-to-4, you would reduce it to a 1-to-2, okay? So this would actually end up just be written like that.
So when we do have 2-4, do you want us to reduce it?
I want you to reduce them. Only for ionic compounds. So I'm going to show you molecular. Don't mess with molecular ones. Okay? But for ionic ones, yeah. Start practicing the reducing, but we will go over that part again tomorrow. So if that just went over your head, don't worry about it. All right. Top of the page, transition metal. Let's just stick with what's up here. We'll look at, actually, we'll do that. We'll do lead 4 oxide. Lead 4 oxide. All right? So, lead. Pb. What is this Roman numeral telling us? The charge. Good. So a +4. Oxygen has a what? -2. So we're going to bring that one down, and we're left with Pb2O4. So what are you going to do with that? Simplify it. PbO2. The only thing I need you to grab from this is that the Roman numeral is the charge. But what? What's that?
Wait, I thought you said to only reduce from the ion. That's not.
For an ionic compound.
So which ones are we not doing anymore?
Molecular, the next.
Oh, okay. That makes sense.
Okay. Sorry. All right, let me speed y'all through this so that way you guys will have time to do your homework. Okay, so now, so all that I need you to grab from that last example was that your Roman numerals are the charges, so that's what you're crisscrossing, okay? All right, so the last thing we're going to cover is this.
Number of prefixes.
We are going to look at
Oh, one English.
molecular compounds. So, what is the one question I've been having you ask yourself first every single time you look at a compound? It's the first question I ask. Is there a metal? Okay, so we're going to write it one more time. And now you'll see why this question is a good question. Okay, because if there's not a metal, what do you know you have? Covalent. And so now you will be naming it using prefixes. So everything that you've had up to this point goes away and you are stuck with prefixes and that's it. Yeah. So the most important question that you can ask yourself is there a metal? If there is, you start running yourself through the processes that you guys have been working on. If you say no, now you're going to rely on your prefixes. Okay? Okay. Prefixes represent what? What do they represent?
Number.
Actually, why don't we go through an example and then you can look. Okay, so let's look at the first one because I think a lot of us are pretty familiar with CO2. Yeah, right? You already know it. It's carbon dioxide. Okay, so there's the prefix in front of the oxygen telling us that we have 2. That's the dioxide, so I'm just getting it from our prefix list right there. Okay, but is there anything that tells us that there's only 1 carbon?
There's nothing attached to it.
There's nothing attached to that one. So this is your first little rule. And then we'll come back to that statement we were writing. Okay? Never put mono next to the first element. Okay? Never put mono next to the first element. It just doesn't go there. You would just write the element as is. If it's any other number, you got to put it there. You got to put the prefixes there. Okay. Your next thing I want you to look at is how this is written. Okay? Because this is representing water. Dihydrogen, 2 hydrogens, monoxide. Please notice that we are not putting monoxide. Do you see that? Monoxide would be weird. Sounds weird. So what you actually do, this is your second little rule, is you got to drop vowels if it's awkward. Okay? An exception to that is you will have, and you'll, trust me, you guys will all ask me the same question as soon as I give you your homework page. But I's, you leave them alone. So if I have triiodide, you leave those I's alone. But if you have monoxide, we say monoxide. Monoxide. So we just drop one of the vowels. So that's your other rule. Drop vowels when needed. Okay. And now that we've gone through those, what do the prefixes represent? The number, right? What is that number called? Subscripts, yeah. Okay? Prefixes represent the subscripts. Your two easy rules are don't put mono in front of the first element and drop your vowels when needed. Another example besides mono oxide would be tetra oxide. We don't write tetra oxide. We write tetroxide. So we drop the A. So here's the tetra, meaning 4. We drop the A, tetroxide. It will come with practice. I'm not expecting you to be experts at it yet. Okay? We got it? Okay. I'm going to give you your homework page and ask me questions as needed. Okay? On this side, you're just going to be taking the formulas and you're going to go ahead and write. You're going to be practicing writing with those prefixes. Okay? So this is where you need to be thinking if there's multiple vowels and things like that. Don't put mono on the first one. Okay? So you're going to practice this for a little bit. You will be completing it for homework, so just get as many as you can done right now. I'm still going to go over that shortcut like I promised yesterday. Okay, so I'm going to show you something else to help you with the other side. But for now, you should just start naming these and get your practice in. You can call me over if you need help. So if you can flip your page over, your homework page, make sure you're on this side. What I'd like to show you, and you probably have enough room up top to kind of write this. Otherwise, you're probably not going to need any of that blank space. Or if you really want to, put it into your journal. I don't care. Just write this somewhere. We're going to focus in on number 7 and number 9 so that you at least have an idea on how to approach the ones that have polyatomics and the ones that have a transition metal. Okay? So for number 7, you have iron 2 fluoride, right? So iron 2 fluoride. So we're going to start with the symbol because now you're writing the formulas for them. We know that it's a transition metal, so that Roman numeral is telling us what?
2.
The charge, exactly. So it's a positive 2 charge. So you're just going to write it in the top right corner for Fe.
Are we using the blank?
You can either do that or up at the top, that little space that you have at the top of your page. Or you can do it to the side. Yep. All right, and now we're going to write fluorine. Fluorine is in group 17. Group 17 has how many, or what charge?
No, wait, I got it. -1.
A -1 charge. So we're going to put that right here. All right, so here's the shortcut part. Once you have everybody's charges,
Why is it -1? Oh,
group 17, yep. Once you have the charges, you're going to take those numbers and you're going to crisscross them. So that 1 is going to go with the Fe.
So Fe, F2.
And the 2 is going to go with the F.
And that's,
So if you want to start writing 1s and stuff, that's fine. But by the end of this chapter, you cannot be writing 1s. Nobody writes 1s. It's weird.
Could be wrong.
Technically, yes, because nobody does that in chemistry.
So do we just get rid of the
Yeah, you don't bring any charges down. What you're doing is you're doing exactly what you guys were doing when you were drawing them, right? You had to have 3 of these and 2 of those, or you had to have 1 of these and 2 of these, right? That's all that this is taking care of. So you can actually go back to your homework last night and you can check all them, and if you crisscross the charges, it matches. And that's all you really have to do to get your formula. Okay? All right, so if I can show you number 9 real quick so that you know what to do with a polyatomic. It's not any different, but just in case you would like a little bit of guidance. That one is sodium carbonate. So we're going to have sodium. Sodium is in group 1, so what kind of charge does it have?
Well,
+1. Carbonate, if you look at your polyatomic list, is CO3, and there is a -2 charge to it. Now, notice I put it in parentheses. That's because if this is ever not a 1, it has to go to the outside of the parentheses when you crisscross them. Okay, so that's why I've been telling you, make sure you put parentheses, It'll help you keep this inside stuff. You don't mess with any of it. It goes on the outside. Okay, that's what that helps you with. All right, but anyway, you're just going to crisscross these like that. You would end up with Na2CO3. And again, we don't write the ones, but if we did, it'd be right there. And that's it. That's the shortcut. So hopefully you appreciate it now that you've had to draw it.
You always put it outside of the parentheses?
Outside the parentheses, always.
Wait, but how do we know? Again,
So
how
why
do
do
we
you-
know